So welcome to all of you. Last time we have seen how to find a partial derivatives of some function. So we'll continue that. So clearance theorem. So what is the statement of the clearance theorem? We have only the statement of the clearance theorem. We are not going to prove this theorem. So suppose f is defined on an open set D, which is a subset of R2, right? Such that contains that D is what, this is what open set, which is a subset of R2. It contains the point AB. So that means AB is the point in D. Now suppose also fx, fy, that means this is the first order partial derivative. This is the second order mixed partial derivative. Fxy and fyx are exist in the neighborhood of AB. Also the functions fxy, that means mixed order partial derivatives. So both are the continuous at AB. Then this mixed order partial derivative at AB are equal, right? This is the clearance theorem. The similar theorem is also Shaw's theorem. So here only the second condition is different here. So same thing as up to the first one, both are the same now. Suppose f is defined on an open set D, which is a subset of R2, which contains the point AB, and also suppose that the first order partial derivative, that means fx and fy, mixed order partial derivative fxy and fyx are exist in a neighborhood of AB. The same condition is also here, the first condition. Only the second condition here. Here what? The both are the continuous function at AB. But here what? Only fxy, or you may take fyx is continuous at AB. Then, so if you are taking here fxy, then what fyx then? It is also exist and both are the equal at the point AB. So this is the Shaw's theorem. In the Shaw's theorem, only the second condition is different. So here what? One of the fxy or fyx is continuous. So then the other is exist and both are the equal. This is the Shaw's theorem. So this is only the necessary condition. This is only sufficient but not necessary. That means what? The converse of the clearance theorem is also not true. The converse of the Shaw's theorem is also not true. So you know that what is meant by a converse. So P implies Q is there, then Q implies P is called converse of Q implies P. So this is what the converse of P implies Q is Q implies P. That means what is P implies? If P then Q. That means if P hold then Q hold. What is the converse? If Q hold then does that imply that if Q is hold then P is hold. So this is not happen in the clearance theorem and Shaw's theorem. That means converse of the Shaw's theorem and clearance theorem are not true. So we'll take some problems. We'll take the problems. Suppose that, okay, let f of xy is equal to x cube y minus xy cube upon x square plus y square, xy not equal to 0 0 is equal to 0, xy is equal to 0 0. Show that fxy 0 0 is equal to minus 1 and fyx 0 0 is equal to 1. Okay, so we want to find the mixed order partial derivative at 0 0. So we'll do this one. Okay, so what we are given? We have given this function. This is the step function. So we'll find this fxy 0 0 and fyx 0 0. So solution, given that fxy is equal to x cube y minus xy cube upon x square plus y square, xy not equal. So what we want? We want fxy 0 0. So we write a definition. So we cannot directly differentiate because this is a step function and this is what 0 0, right? So fxy not equal to 0, this is 0, right? So we need to apply the definition of the that means what the limit definition of the partial differentiation. So first what we are doing? We are differentiating fx with respect to y now here. Partial differentiation of fx with respect to y. So we are differentiating fx partial with respect, that means what? Limit k tends to 0 because we are differentiating with respect to y. Partial differentiation with respect to y. So fx, you have to increase the your y coordinate of fx. So that means what? This is 0 k because 0 plus k, 0 plus k is k now, minus fx 0 0. Your f is fx now, so this is k. To evaluate this, what we need? We need to evaluate fx 0k and fx 0 0, and we put here. So we call this as 1 now. So we cannot divide this directly because we want this first derivative with respect to x, that is first order derivative with respect to x at 0k, and here what? At 0 0 8. So we find first fx 0k. So that we are differentiating with respect to x now. So we'll take h is equal to 0. So what? We have to increase your x coordinate by h now. So f hk minus f0k upon h. This is your formula. So we put the f of hk and f of 0k. So f of hk means what? Your h, k tends to 0, k not equal to 0, h tends to 0, h is not equal to 0. So we put, that means what? Xy not equal to 0 0. Here we will put x is equal to h and y is equal to k. So what happens? So this is what? Limit h tends to 0, h cube k minus h k cube upon h square plus k square minus. So this is upon h minus f of 0k. That means this is 0k also. If your k is not equal to 0, right? That means xy not equal to 0. So what we will do here? We'll put x is equal to 0 and y is equal to k in your original function. So if you put x is equal to 0, your numerator becomes 0. That means everything is 0. So this is 0 now. Right? So now this is what? Limit h tends to 0. So here we will take h common. So h common, h square k minus k cube upon h into, this h will be here, h square plus k square. Right? Now your h get cancelled. So this is equal to limit h tends to 0. This h get cancelled. So what we get? h square k minus k cube upon h square plus k square. Now see, this is not a 0 by 0 form. We can put h is equal to 0 here. So what we get then? If you put h is equal to 0, so we get minus k cube upon k square. Right? So what we get then? This is minus k. So your fx 0k here we write here. So fx 0k. So therefore fx 0k is equal to minus k. Fx 0k is equal to minus k. We will put in one day. First also we have to evaluate fx 0 0. So we will evaluate fx 0 0 now. This is simple. So now what? We are differentiating f with respect to x. So limit h tends to 0. So we have to increase your x coordinate by h. So this is f of 0 plus h, that means this is h 0 minus f of 0 0 upon h. We will put f h0, limit h tends to 0. So what we have to do? We have to put x is equal to h and y is equal to 0. So see, this is the product of x and y, this is the product. That means one of the x and y is 0, then everything is 0. So this is what? 0. And for this is directly given, this is 0 upon h, right? So this is what? So 0. Limit of 0 is 0. So fx 0 0 is what? 0. And fx 0k is minus k. So what we will do? We will put this value in 1. Okay. So from 1. From 1 fxy 0 0 is equal to limit k tends to 0. What we get? This is minus k. This is 0 upon k. So this is what? Limit k tends to 0. So minus k upon k is minus 1. Right? And limit of constant is constant. So this is minus 1. So this we want to prove that. This question is show that what? fxy 0 0 is equal to minus 1. That means we are true. Now what we have to do? We will find fyx now. Fyx at 0 0. So we write the formula for that one. Fyx 0 0. So what we are doing here? We are differentiating fy partially with respect to x. So that means what here? We have to differentiate fy partially with respect to x. So this is what? Limit h tends to 0. So we are differentiating fy. That means what? Your f is what? Your fy. Increase your x coordinate by h now. So increase the x coordinate of fy by h minus fy 0 0 upon h. So this is called this as 2, right? Because we don't have direct value of this one. We have to find the value of fy 0 and fy 0 0. So we'll find the value of fy 0 and then we'll find fy 0 0. So fy h 0, fy h 0. That is what here we have to differentiate f partially with respect to y now. So we are differentiating partially with respect to the. So we have to take the limit k tends to 0. Now we have to increase your y coordinate by k. So that means what? We increase the. So we are differentiating f partially with respect to y now. So we have to increase the y coordinate of f now. So here what? We are increase the x coordinate of fy. So here fy. So here what? We increase fy, right? hk minus f h 0. This will be as it is, f of h 0. Only have to change your y coordinate upon k. We'll put the value here. Limit k tends to 0. fyhk. So fyhk means what? h cube k minus h k cube upon h square plus k square. Now see, this is what you have to apply this all. Put x is equal to h here and y is equal to 0. But if you put if you have one of the x or y is 0, then everything is 0. So this will be what? 0. Otherwise what? So put x is equal to h here and y is equal to 0. Now see, your numerator is 0. So don't go through the denominator. So numerator is 0, then that is 0, right? So your denominator is not 0, not that. Denominator is what here? H square. It is not equal to 0. Your numerator is 0, therefore it is 0. So upon k. So this is what? Limit k tends to 0. Limit k tends to 0. We'll take k common now here. K common. H cube minus h k square upon, the k will be here now. So k into h square plus k square. Now your k get cancelled. Your k get cancelled. So this is what? Limit k tends to 0. H cube minus hk square upon h square plus k square. Now this is not 0 by 0 form. So put k is equal to 0. If you put k is equal to 0, so what we get? Limit k tends to 0. Oh, no need to write now limit now here. We are taking k tends to 0. So we are taking the limit now. So this is what? H cube upon h square. So this is h. Right? So therefore what? Your fy h0 is h now. So fy h0 is h. Write this h. Now we have to find this now. Fy 0 0. So we are differentiating f partially with respect to y. So we will take limit k tends to 0. F of 0k minus f of 0 0. This is the definition upon k. So we put now the values of f 0k and 0 0. So f of 0k is 0. F of 0 0 is given to you. This is 0. So this is 0. Right? So we get the value of fy h0, fy 0 0. So we put the value of this into. So we get. So from 2 fyx 0 0 is equal to limit h tends to 0. So what is the value of this one? Is h minus 0 upon h. So this is what? Limit h tends to 0. This is 1 and limit of constant is constant. So this is this. So therefore f of xy 0 0 is equal to minus 1 and fyx 0 0 is equal to 1. Right? So we have proved this one. That means we are true. So remember this formula. You should remember this formula. Then you can solve any problem on this fxy, fys. Okay? So we'll take another problem. So that you will understand the definitions, how to apply that definition. So we'll take fxy is equal to, next problem, fxy is equal to x square y square upon x square plus y square, xy not equal to 0 0, is equal to 0, so xy is equal to 0, 0. Show that fxy 0, 0 is equal to fyx 0, 0. Try to show that they are equal now here. So in the previous problem what we have seen, they are not equal. Okay, so now again we'll find on the similar way. So what is this? We have given this function. Okay, solution given that f of xy is equal to x square y square upon x square plus y square. Xy not equal to 0, 0. Xy is 0, 0. Okay, so what we want, we will find first fxy mixed order partial derivative. So take this fx. So here what we have to differentiate fx partial with respect to y now. So we take limit k tends to 0. We are differentiating fx with respect to y. So we increase your y coordinate of fx by k now. So this will be fx now. You have to increase your y coordinate. So 0 plus k is k now. So fx 0, 0 upon k. First we need to find fx 0 k, fx 0, 0. So we call this as 1, right? So we'll find the values of fx 0 k and fx 0, 0. We'll put the values of fx 0 k and fx 0, 0 in here, and then we get this mixed order partial derivative. So we'll find fx 0 k now. So fx 0 k. Now here what? We are differentiating f partially with respect to x. So we'll take h tends to 0. So we are differentiating f, right? So what you have to with respect to x, that means we have to increase your x coordinate by k. So this is what f of hk minus f of 0 k upon h. So this is what limit h tends to 0. So we'll find fhk in this. So this is what then h square k square upon a square plus k square, a square plus k square minus, see this is the product x and y. So that means what, one of them is 0, then the value is 0 now upon h now. So this is what limit h tends to 0. So now h will be here now, h square k square, this h will be here now, h square plus k square. Now one h get cancelled. This is what limit h tends to 0. One h get cancelled. H k square upon h square plus k square. Right? Now see, this is not a 0 by 0 form. Your numerator is 0 but denominator is not 0. Your denominator is what, k square. So if you take the limit, so limit will be 0 now. This is what, 0. Because if you put h is equal to 0, your numerator is 0. But what is this? This is what you will write this what, 0 upon k square. So now k is not equal to 0. K tends to 0, k is not equal to 0. That means what, 0 upon k square is 0 now. Okay. So this value is 0 now. Now we'll find fx 0, 0. So fx 0, 0. Fx 0. Most of the problem, so the value of 0, 0, fx 0, 0 is 0. But you need to find this. So limit h tends to 0. This is very standard definition now. F of 0, 0 upon h now. So this is what limit h tends to 0. Now see, this is the product of x and y. So if one of them is 0, then the value is 0. 0. This is directly given 0 upon h. So this is 0. So that means what? So fx 0 k is 0, fx 0, 0. So from 1 fxy 0, 0 is equal to limit k tends to 0. So this value is 0. Fx 0, 0 is also 0 upon k. So this is what, 0. So fxy 0, 0 is 0. So we want to show that fxy 0, 0 is equal to 0, and we have proved this. So now we will find the second mixed order partial derivative, fyx now. So here the formula is very important now. You should remember the formula. So if you don't remember the formula, you cannot solve this problem. Okay. So what we are doing here, we are differentiating fy partially with respect to x now. Partially with respect to x now. So we will take the limit h tends to 0. So what we are differentiating fy. That means you have to increase your x coordinate by h, right, of fy. So fy will be here now. Increase your x coordinate by h now. So this is 0 minus fy. So same point will be here. 0, 0 will be 0, 0, 0 upon h. Now we cannot evaluate this directly. So we need to find fy h0 and fy 0, 0. So we find fy h0. Fy h0. So now this is fy. We are differentiating f with partial with respect to y now. So we take limit k tends to 0. Limit k tends to 0. Now we will increase your y coordinate by k now. So of f now. So this is f because we are differentiating f with respect to y. So this is h will be as it is. Your x coordinate will be as it is. Your y coordinate will increase. Add k in the y coordinate. So 0 plus k is k minus f of h0. This point will be here now as it is. Only you have to make the in the first term you have to increase your y coordinate by k only. Other as it is now. So this is what. Okay. The second term. So and the coordinates are as it is. So what you need? You have to find the value of f of hk and f of h0. So obviously this is 0, right? Because your y is 0. If I put y is equal to 0, then it is 0. So this is what. So this value is 0 now. We have to evaluate only this one, right? So limit k tends to 0. So this is what h square k square upon h square plus k square minus 0 upon k. Now k will be here now. So this is what limit k tends to 0. H square k square upon k into h square plus k square. Now h get cancelled. So this is what limit k get cancelled. Limit k tends to 0. So this is what h square k upon h square plus k square. Now see this is not 0 by 0 form again. So if you put k is equal to 0, your numerator is 0, but your denominator is not 0. So this is what 0 upon h square. This will be 0. Your h is not equal to 0. Limit h tends to 0 here. H is not equal to 0. So also k is also not equal to 0. So what we get? We got fy h0 is 0, right? So we need to find fy 0, 0. So we find fy 0, 0, and then we'll put in 2, and the problem will be over then. Okay. So fy 0, 0. Now this is usual formula. Now we are differentiating with respect to y. So we'll take limit k tends to 0. Increase your y coordinate of f by k. So this is 0 k minus f of 0, 0 upon k. Now see, this is what limit k tends to 0. Your one of them is 0, then what? It is 0. So f of 0, 0 is directly equal upon k. This will be 0, right? So we get the value of fy h 0. We have the value of fy 0, 0. We will put both the values in 2. So from 2 we get fy x 0, 0 is equal to limit h tends to 0. This value is 0 minus 0 upon h. So this is 0, right? So we are through now. fxy 0, 0 is equal to 0. This is equal to fyx 0, 0. Okay, so we are through now. The problem is over. So I hope that you understand this one. Only what we have to do, we have to write the formula, right? Write the formula correctly, right? If you don't remember the formula, you cannot do anything now, right? So you should remember this formula, right? So this is for 0, 0. So we have seen the formula in terms of AB also. Your A is 0, B is 0. Okay, we'll take another problem. So let f of xy is equal to xy mod y is less than mod x, less than or equal to, and here minus xy mod x is less than or equal to. Okay, so we will write y here and just only this now, right? We reverse the inequality only. show that fxy 0 0 not equal to fxy 0 0 not equal to 0 0. Okay, so what we have to do only, we have to prove that they are not equal. That means what, we'll find the values of fxy 0 0, we'll find fy 0 0, and then we will judge this they are equal or not. So question may be like this, prove or disprove. That means whether they are equal or not, we have to confirm this. So solution, given that f of xy is equal to mod xy, so if mod y is less than or equal to mod x and minus xy is mod y is greater than mod x. Okay, so we'll write the formula. Okay, so what is the formula for, we'll find plus fxy 0 0. We'll write the formula for limit. So we are differentiating fx, your f will be what, fx, right? We are differentiating with respect to y, so we'll take limit k tends to 0. Your f is fx, increase your y coordinate by k, that means this is 0k, then minus fx, your coordinates are same now here, 0 0 upon k. So we call this as 1 now, right? Because we need to find the value of fx 0k and fx 0 0. Okay, so we find fx 0k, fx 0k. So limit here what, h tends to 0, 0k. So f h0 minus f hk. You have to increase your x coordinate by h now. 0 plus h is your h, your k will be as it is, f0k minus f0k upon h now. Now we have to put the value of this one. We have to put the value of this one. Your h tends to 0. Your h tends to 0. That means h is what, less now. So that means what? So here what? Here h tends to 0. That means h becomes smaller and smaller. So that means your x becomes smaller and smaller. So your x is small. That means what here? So therefore mod h is less than mod k. Right? So we have to apply this formula now. So fx 0k is equal to limit h tends to 0, minus hk minus, so now this is product now here. So what here again, here what your this is same now. So you have to apply minus hk also, but it is 0. So this is 0 upon h. So this is limit h tends to 0. So limit h tends to 0. This is what, minus k. So this is minus k. This is minus k. Right? We get a minus k. Now we get this value fx 0k is what, minus k. We'll find now fx 0 0 now. So we'll find fx 0 0. We'll find the value of fx 0 0. So fx 0 0 limit h tends to 0, f of h 0 minus f of 0 0 by our definition now upon h now. Now we'll put here, if see one of them is 0, then this is 0, right? So this is what, then limit h is 0. So here what, here xy, here minus xy. So now if one of them is 0, so don't bother about this one, right? So what is this? This is what, 0 minus 0 upon h. So this will be 0, right? Now we'll put in 1, we get the both the values, right? We'll put in 1, but we get then, so from 1 fxy 0 0 is equal to limit k tends to 0 minus k minus 0 upon k. So this is what, limit k tends to 0 minus 1, limit of constant is constant. So your fxy 0 0 is equal to minus 1. We call this as a now. We'll call this as a. Now what we want to do, we want to show that fxy 0 0 not equal to fyx 0 0. So we'll find now fyx 0 0. So we'll write a formula for fyx 0 0. fyx 0 0. fyx 0 0. We write the formula first. Limit. We are differentiating fy partial with respect to x now. So what we do? Limit h tends to 0. Your f will be what? Your f will be what? Fy. We have to increase your x coordinate by h now. So fy will be anything. This is 0 minus fy 0 0 upon h. Right? We call this as 2 now. Right? We will find the value of fy 0 and fy 0 0. Then we put the value of fy 0 and this, and then where it is limit, that will be the value of fy 0 0. Right? So we will find this fy h 0. So fy h 0. So this is what we are differentiating with respect to y. So limit k tends to 0. Your f will be f now here. You have to increase your y coordinate by k now. So f of hk minus f of h0 will be as it is upon k. Now here k tends to 0. Your k tends to 0 now. K becomes smaller and smaller. So k becomes smaller and smaller here, right? So that means what? Since we write here. Since k tends to 0, therefore mod k is less than r equal to this h now. Right? Less than or equal to r this. Right? So now which function we have to apply? See your k, this. Right? A plus xy, right? Okay, so fy h0 is equal to limit k tends to 0. This is hk now. You have to take the positive value of this one because your mod k is less than mod h. That means your mod y is less than mod x now. Because your y coordinate becomes smaller and smaller, right? And there is no restriction on the x coordinate now. Minus, if one of them is 0, then this is 0, whatever this may be, right? So this is 0 upon k, right? Your k get cancelled. So limit what? K tends to 0 of h. So this will be h now, because where this is k tends to 0, h is independent on k, so limit of constant is constant. So we get h now. So we find fy 0 0 now. Fy 0 0. So fy 0 0 is what? Limit k tends to 0. F of 0k. This is very simple now. 0 0 upon k. So this is equal to. If one of them is 0, then the value is 0 now. So now we have 0k, value is 0 now. So 0. F of 0 0. This is also 0, right? Upon k. So this is 0. Right? So now we'll put the values of fy h0 and fy 0 0 into. Okay, so from 2 we get fyx 0 0 is equal to limit h tends to 0. So this value is h now, minus 0 upon h. So this is what? Limit h tends to 0. Your h get cancelled. So this is 1 and limit of this is 1 now, right? So therefore fyx 0 0 is 1. So call this as b. So what is your from a? So that will be minus 1. Your fy 0 0 is what? Fy 0 0 is what? Minus 1 and this. So from a and b. So 1 and minus 1 are not same. So from a and b, fxy 0 0 not equal to fyx 0 0, right? Because this value is minus 1 and this value is 1, right? So they are not equal. So the problem is over now. I hope that you understand this one, right? So this is very simple problem. All the three problems were very simple problem, right? So now Laplace equation. So the differential equation dou 2 u by dou x square plus dou 2 u by dou y square is equal to 0. Each called Laplacian is called Laplacian equation or Laplace equation, just Laplace equation. Laplace equation. Okay. Then wave equation. Wave equation. The differential equation. The differential equation. Dou 2. The differential equation. Dou 2u by dou t square is equal to a square dou 2u by dou x square is called wave equation. A wave equation where u is equal to u of tx now, and here u is the function of x and y, right? So if you satisfy this Laplace equation, then that function is called harmonic function. It's called harmonic function. So harmonic function. We'll write definition of harmonic function. Harmonic function. Harmonic function. Harmonic function. That means what? A function which satisfy the Laplace equation is called harmonic function. A function which satisfy Laplace equation is called harmonic function. Right? That means what? So if problem is asked like this, what? Show that the function is harmonic. Right? Show that it satisfies the Laplace equation. So Laplace equation is what? You have to differentiate u with respect to x, again with respect to x. You have to differentiate u, y, again with respect to y, and take the sum of this one. Show that that sum is what? 0. Right? So differentiate, double differentiation with respect to x, double differentiation with respect to y. Take its sum, show that it is equal to 0. Right? If the sum of this is 0, then it is what? It satisfies the Laplace equation, and it is also called as a harmonic function. And this is the wave equation. So where a is constant. Okay. So show that the function u is equal to, e raised to x sin y is a solution of Laplace equation. Laplace equation. Solution. Given that u is equal to e raised to x sin y. So what we will find? U xx. Then find u yy. And we'll prove that sum is what? 0 now. So u xx. Very simple problem. U x now first. Okay. So differentiate partial with respect to now. Derivative of e raised to x is e raised to x. Your sin y is constant. Right? So we are differentiating with respect to x. Right? Keep other variable as a constant. Treat other variable as a constant. Your sin y will play the role of the constant function. Now again we will differentiate this one. Again what? Derivative of e raised to x is e raised to x sin y. Right? So u y now. So what? E raised to x cos of y now. Because now e raised to x is constant, cos of y. Again differentiate this. What? U y y. Derivative of cos y is minus sin y. So this is e raised to y sin y. We call this as 1. We call this as 2. So 1 plus 2 gives. We'll take the sum of RHS to RHS side, LHS to, right? So they are equal but opposite. So this will be what? 0. Right? So therefore u is a solution of Laplace's equation. Laplace's equation. Your Laplace equation. Right? So just right. Very simple problem. So you can solve number of problems on this, right? Show that is what? A solution of Laplace equation. Right? Just you have to double differentiate with respect to x, double differentiate with respect to y, take the addition. So verify that u is equal to u is equal to x square plus y square plus z square to the power minus half is solution of Laplace equation. Now see, this is a 3-dimensional. No problem for here. This is there. Solution. That means what? Only at what? This is what? uxx plus uyy. This is for 2 variables. We have 3 variables. We z now. If you have 4 variables, suppose w is also added. So what? Plus uw is equal to 0, right? That will be your Laplace equation, right? So this is what 3-dimensional equation. 3-dimensional. So that means what? You need to double differentiate with respect to z also now. We have to add one more term now here. So solution, given that u is equal to x square plus y square plus z square to the power minus half. We will double differentiate with respect to x now. First we will differentiate with respect to x, then we will differentiate with respect to x again, right? So what your power is there, so pull the power now. This is what? X square plus y square plus z square to the power. You have to reduce the power by 1 now. Minus 1 minus half. So minus half minus 1. This is what? Minus 1 minus 2 upon 2. So this is minus 3 by 2. Minus 3 by 2. Again we have to difference into. See, this is what? Something to the power n. So you have to pull the power, reduce the power by 1 and multiply the derivative of the bracket now. Partial with respect now. This is twice x now. Okay. So ux is equal to what? So these two get cancelled. So minus x square plus y square plus z square to the power minus 3 by 2. Again we have to differentiate with respect to x now. But note that here your minus x and this will what? This contain a this is also function of x. This is also function of x. So you need to apply the product rule now. So while differentiating with respect to x of ux, you need to apply the product rule. So minus x will treat as a function, one function, and this. So your minus x will be as it is now. We differentiate this now. This is what? Minus 3 by 2, right in bracket. Minus 3 by 2. Right? Reduce the power by 1 now. This is what? X square plus y square plus z square to the power minus 5 by 2 into twice x. Just we have taken the derivative of this only. Right? We have to take the derivative of now minus x plus x square plus y square plus z square minus 3 by 2 as it is into derivative of minus x, that will be what? Minus 1. So what we will do now here, so this is what these two get cancelled. So what we will do, so can we take the common? Okay, keep as it is now. This is what? So 2 get cancelled only. So this is what? Minus 3. Minus also get cancelled. So this is 3x square now. X square plus y square plus z square to the power minus 5 by 2. Then this will be the minus now. Minus x square plus y square plus z square to the power minus 3 by 2. To the power minus 3 by 2. This is what your uxx. Now see what will be your y now. So what happened in y? Only what here? This will be as it is now. Your y will be here. Right? So again we have to take the product rule. So your what here? We get twice y here. Right? This y here, twice y here, and this minus will be as it is. So that means what? For uyy, what you get here? 3y square, and all the terms are as it is. So we can say similarly. So we'll say similarly. So no need to differentiate this one with respect to y and with respect to y, then with respect to z. So what happens if you are differentiating with respect to z now? So what we get here? Only 2z. 2 get cancelled your z. Again you are differentiating with respect to z, man. That means we have to apply the product rule again. So what we get? Your z will be, your twice z will be as it is. So what we get here? 3z square now, right? So for z, that means what? So we can say similarly, what? Uyy is equal to 3y square x square plus y square plus z square is equal to minus 5 by 2. Now see here, if you interchange the roles of x and y, the function will be same now here. If you change the role of x and y, right, x as z and z as x, so then the function is still same now. Then what you can write it. Similarly, if you change the role of the x and y, so what we get again, the function is same now. That means what? So only what here you have to change, right? Replace what? See, the odd term will be what here, twice x square. Just only change that term. So minus x square plus y square plus z square to the power minus 3 by 2. We call this as 1. We call this as 2. Similarly, you write uzz is equal to what? 3z square. So this is what? X square plus y square plus z square to the power minus 5 by 2 minus x square plus y square plus z square to the power minus 3 by 2. We call this as 3. Okay? So we'll add this 3 now. We will add this 3. So 1 plus 2 plus 3 gives. So what is this? uxx plus uyy plus uzz. Now see here. You cannot cancel this because what? You will not get this, what? So you cannot cancel this. So what happened here now? So you have to add these 3. So here what? Your 3 x square y square x square plus y square plus z square to the power minus 5 by 2 is same everywhere. So we'll take that common now. So this is what? X square plus y square plus z square to the power minus 5 by 2 common, right? So everywhere. Now what we get there? X square plus y square plus z square. X square plus y square plus z square minus. Now all the three terms are same now. So minus 3 x square plus y square plus z square to the power minus 3 by 2 now. Now see, what the base is here, power is 1 now here, right? The base is same. That means what? This is a product, right? So that means you have to take the sum of the indices. Minus 5 by 2 plus 1 now. This will what? 3x square plus y square plus z square minus 5 by 2 plus 1. This is what? Minus 5 plus 2 upon 2. So this is what? Minus 3 by 2. So minus 3 by 2 minus 3 x square plus y square plus z square to the power minus 3 by 2. Now see, we get 0 now, right? So okay, so if problem is asked on Laplace equation, solve that problem, because what? So solution is what? 0. If you get 0, that means surely your problem is correct now, right? So don't drop the problems on the Laplace equation, right? So I hope that you understand this one. Only problem is your what? So your role is very important. You have to differentiate correctly, right? If you are not able to differentiate with respect to x, with respect to y, you cannot do anything in the partial differentiation. That means in the calculus of this is the calculus of multivariable calculus, right? Even though you can't do in the vector calculus, which is in the second semester. Okay, so now take the next problem. Verify that the function u of xt sine of x minus 18 satisfies wave equation. Okay, so you know that the wave equation is what? Uxx is equal to minus, what is wave equation? Uxx utt now. Utt is equal to a square uxx now. Xx. That means what? Some constant multiplier value. You may write here 1 by a square, doesn't matter this. Okay, solution. We'll find first uxx. Just find uxx and utt, right? You will get the wave equation. If you equate that, you will get the wave equation. So ux, first we will find ux now. Differentiate partially with respect to x now. Derivative of sine is cos of something into derivative of something, right? So derivative of x minus 80 with respect to x is 1 now. Then uxx Again we have to differentiate cos. Now this will what? Minus sin x minus 80 now. Okay, we call this as 1 now. Then ut now, ut is equal to sine of something, cos of something. So cos of something x into derivative of something. So this is minus a, right? Again utt to differentiate. Cos of, this is what derivative of cos is minus sine of x minus 80 into minus a, derivative of x minus 80 is minus a, and your first minus a will be as it is now, right? So what we get now? utt. So your suffix, this is what level should be. You have to maintain the level of utt, right? It is a suffix. So minus this plus, so minus a square sine of x minus 80, right? Now see here, what is your sine of, so minus sine of 80 is uxx. So utt is equal to a square uxx. So no matter what, you may write this what, uxx is equal to a square utt. That is also the wave equation, right? So we get the, therefore you satisfy the wave equation, and we are through now. Verify that. We take the next problem. Verify that the function z is equal to ln. So ln means log e raised to x plus e raised to y is a solution of the differential equation. Is solution of differential equation zxx zyy minus zyx bracket square is equal to 0. Okay, so what you have to do, you have to double derivative, you have to find a double derivative with respect to x, double derivative with respect to y, and the mixed order partial derivative, right? So we'll take this solution. Okay, no problem, this is very easy now. Okay, solution, given that z is equal to ln e raised to x e raised to y. Okay, so first we'll find zxx. So zxx is equal, first we'll find zx, right? Then we'll find zxx, right? This is ln is log now. So log of something, so 1 upon something into derivative of something, So derivative of this is what? So this is e raised to x upon e raised to x plus e raised to y. You have to apply now u by v rule now. So e raised to xx, like that. So numerator, denominator. Now denominator as it is, into derivative of numerator minus numerator as it is into derivative of denominator. Derivative of denominator is e raised to x. Derivative of e raised to y will be 0. So what happened now? This is upon the square of the denominator, e raised to x, e raised to y, bracket square. So what we get now here? E raised to x into e raised to x get cancelled. So this is what? E raised to x, e raised to y upon e raised to x plus e raised to y bracket square. Okay, we call this as 1 now. Now we'll find, so this zyx, so we need zy, and then we'll differentiate over zy with respect to x for this one. First we'll differentiate this zyy. Now see, for zyy, so what we get now? The same thing here. Zyy will be the same thing, because what? This will what? E raised to y now. E raised to x plus e raised to y. So what we get now? This is what? E raised to y will be here, right? E raised to y, e raised to y. That means what we get here? E raised to x, e raised to y. This will be same now. If you change the role of x and y, your function is as it is now. So that means here what? Here also change the role of x and y. So what we get? The same thing now. E raised to x into e raised to y upon e raised to x plus e raised to y bracket square. If you are not able to understand this one, just do your own. This is what? Zy is equal to what then? zy is equal to e raised to y upon e raised to x plus y. Then apply the u by v rule. E raised to x, e raised to y as it is. Derivative of e raised to y will be e raised to y. Your e raised to y will be as it is. Into derivative of the denominator will be e raised to y now. So your e raised to y, e raised to y, here e raised to y, e raised to y get cancelled, right? Then this is e raised to x, e raised to y will be as it is now, right? So your z y y y is also as it is. So but for this z y x you need zy actually. Okay, so call this as 2. So what is your zy? Zy is what? E raised to y upon e raised to x plus e raised to y. Now we find zy x now. We find zy x. Again you have to apply u by v rule. So now e raised to y is a constant and this is 1 upon something, right? So derivative of 1 upon something is what? Minus e raised to y, e raised to x plus e raised to y bracket square, right? Well, derivative of 1 by x. Derivative of 1 by x is what? Minus 1 by x square. But derivative of 1 upon f of x is what? Minus 1 upon f of x whole square into f dash x. Into derivative of something. So derivative of e raised to x plus e raised to y. So that with respect to x is what? E raised to x now. E raised to x, right? So this is equal to what then? Minus e raised to x, e raised to y upon e raised to x plus e raised to y bracket square. Right? Now we want to show that this is a solution. That means what? Z satisfies this equation. So we'll take the LHS and we'll prove this is what? 0. So we'll take LHS. So LHS is equal to this. Your ZXX is what? E raised to x, e raised to y upon x square plus y square bracket square. Your ZYY is also same now. E raised to x, e raised to y upon x square plus y square bracket square minus. Now square now. Minus e raised to x, e raised to y upon e raised to x plus e raised to y bracket square. Bracket square. Apply the rule of the indices. What we get? So this is what? E raised to apply the rule of the indices. So this is what? Twice x e raised to twice y upon e raised, what is this? X square. E raised to x, e raised to y, e raised to x, e raised to y. Okay. So that means what? This is what? E raised to x plus e raised to y raised to 4 now is minus. Now if we are taking the square of this one, the minus might become plus now. And again this is what? E raised to twice x, e raised to twice y. You may take the sum, doesn't matter. This is what? E raised to x plus e raised to y raised to 4. Now both are the same now. So this is 0, right? So that means we are through. Right? So only we have to take the adjustment. This is what? This is a simple algebra. So you should able to this. Right? So here we have taken the care of this one. So something to forward e raised to a raised to m to the power n is nothing what? A raised to mn, right? This is the rule of the indices we have applied here. I hope that you do this. You can do this one, right? So this is the end of the lectures. I hope that you understand this one, right? So try to solve the problems on the partial derivatives which are given in the exercise. Okay, thank you.